Hi, Secondary 2 Honors class, my first period, who is at home now and not at my class or at the school. I love Miss You. We're going to do Unit 18, so we're starting a whole new unit. It is Introduction to Trigonometry. Trigonometry comes from the Greek word trigon and metron. All right, trigonon, I guess. I think it is, if I remember right. It's been a while since I looked it up. But trigonon means triangle, and metron means measure. And that is all trigonometry is. Trigonometry is really cool. I love it. And all it deals with is measuring angles and sides of a triangle. So you have 6 basic measures. And it's something very important for when you get into secondary 3 and calculus. It's a whole new world of functions that you haven't ever probably seen before, though you might have seen them here and there with different things because they're very useful in sound waves or any type of waves, like your cell phone waves. Trigonometry basically has 3 functions: sine, theta, cosine theta, and tangent theta. Those are the functions. Sine theta looks like this, looks like a sine wave. Cosine theta looks like this. They go on forever in between 1 and -1, unless they've been moved. Tangent theta, I can't remember the first one. I think it goes through the origin. Looks like that. All right, so they're all functions. They have graphs. They have everything to do with them, but it's really odd that, or not odd, but it's very important to know that we use trigonometry a lot with triangles. Now, they're not just tied to right triangles. Well, they are tied to right triangles, but there are formulas and things we can use sines with and cosines with to find side measures and angle measures of non-right triangles. But for our start and what sines, cosine, and tangents are most generally used for are right triangles. So with that introduction, I'm really excited about doing trigonometry. It's one of my favorite types of classes to teach, and love it. 18.1 starts with the Pythagorean theorem. The Pythagorean theorem is something you should already know if you have a triangle. It's important to note, I like to even write it backwards, which one is the hypotenuse. The hypotenuse is the longest side, and it's across from the 90-degree angle when we're dealing with Pythagorean theorem. Pythagorean theorem can only apply to right triangles. That's the only time we can use the Pythagorean theorem. So that's important to note. If it's not a right triangle, then you can't go to the Pythagorean theorem to come up with a side. All right, and beyond that, even though it has to only be a right triangle, the other thing is it's the hypotenuse that is by itself. So we know we take 2 sides, we square them, and we sum them, and we set that equal to the third side squared. And the main thing that I think a lot of times we don't realize, or maybe we're not taught that way or whatever, it is the hypotenuse squared that is alone on one side. It's the longest side. So the longest side, the hypotenuse squared, is equal to the sum of the square of the 2 sides. Oops, b squared. So a squared plus b squared equals c squared. It's important to note that it is the hypotenuse, the longest side, that is all by itself. So we know every triangle has 3 sides, right? That's all. Definition of a triangle. Tri means 3, right? So every right triangle has sides with certain names. So we have a longest side, we have 2 shorter sides. The longest side is always the hypotenuse, and the 2 shorter sides are what we call the legs. So the legs also, if you're not sure just by the picture which one's the shorter side or not, note that the legs form the right angle. So here's a leg and here's a leg. They form the right angle because the 2 sides are shorter, of course, and, well, there's not really a reason anyway but the legs are called legs because they form the right angle. So in reference to the figure above, let's see, A and B are the legs, and then C is the hypotenuse. All right, so always locate the 90-degree angle, go straight across from it, just carry your eye straight across from that 90-degree angle, and that is going to be the hypotenuse. And I always find that first. And then I look to see which legs run into the right angle, form the right angle, which sides form the right angle, and we call those legs. All right, give a written description. You guys can write this out. How can you tell which side is the hypotenuse? You can write whatever you want. It's this side opposite the 90-degree angle. All right, or it's the longest side. It has to be because it's opposite the greatest angle. 90 is the biggest angle. The other two are going to share 90, so they're going to be less than 90. But that 90-degree angle across from it is going to be the longest side because it's across from the greatest angle. Remember my little triangle diagram here between my palms and my fingertips. This side, the imaginary side, is the opposite side, right, of this angle. And the bigger the angle is, the longer the side will be. The shorter the angle is, the shorter the side across will be. So you have that information. You note that if I have the biggest angle of these three sides, the bigger the angle, that side's going to be across from the angle is going to be the biggest side, the longest side. So whichever you want to say, or however you want to say that there, that should be in your own words. So let's look at a few examples. Example 1 says, which side is the hypotenuse, and then solve for x. So hypotenuse, you can locate the 90, look right straight across from it. It's the 16-foot side is hypotenuse, right? So you can just label that hypotenuse right there. All right, and then to solve for the other side. Now, I'm going to show you a couple little shortcuts, which I love shortcuts. They're very, very cool. I'm going to show you why first. And then basically the shortcuts allow you to set up any of your Pythagorean theorems without where it's just that side is equal to. So instead of saying hypotenuse squared is equal to a squared plus b squared, and then subtracting and adding or whatever, and then square rooting, and then that leaves you with something that x equals. Instead of doing that every single time, knowing what you know, what sides you have, you can set up just that side equals, and you can have something already. But I'm going to show you why. So I have 10 squared plus x squared is equal to 16 squared. All right? So I just subtract 10 squared, and notice I'm not even squaring them or anything. I just have x squared equals 16 squared minus 10 squared. And then if I have x squared, I undo that by square rooting, and that leaves me with x squared equals 16 squared minus 10 squared. Okay, now notice something. The side that we did not know was a leg. Okay, the leg, if I don't know the leg, this is what I can set up every time, because solving gets you there every single time. So if I have a leg that's missing, so therefore I have the hypotenuse and a leg, all I need to do is start at this step right here. I can just say x equals, and then the square root of the hypotenuse squared minus the leg squared that I do have. And you can just plug that into your calculator as you see it. I'm going to bring this over here, except I kind of forgot. Let's see. I'm wondering if I can set this up to where it's not going to glare. I don't think it is. So square root of, what was it, 16 squared minus 10 squared. So square root of 16 squared minus 10 squared is, you can just set it up just like that in the calculator. All right, and you get 2 radical 39, which is the, what's it called, the exact answer. If I go down here and hit this little toggle button right here, that little toggle button, it will tell me the approximation. So 2 radical 39 is exactly what it is, but we know radical 39 is an irrational number. We don't have the whole number because we can't, it never ends, but we do know it's approximately 12.5. So with that, we've got, we can write 2, that always happens, 2 radical 39, or approximately 12.5. That's what x is equal to. Pretty cool, right? Not too bad. So example 2, which side is the hypotenuse, and solve for x. So the hypotenuse is right here. It's across from the 90. Okay. And here we have our two legs. So we have 9 squared plus 4 squared is equal to x squared. So setting that up, we know that we immediately have to square root because we have x squared equals, we undo the square by square rooting, and we have a 9 squared plus a 4 squared. So let me get my red pen out here. I can just start right here. If I'm solving, I know that the hypotenuse is always going to be, x is always going to be the square root of the sides summed and squared. So 9 squared plus 4 squared. All right, now notice the difference here. Here, it was the hypotenuse I was missing, and I have the other two sides, 9 squared plus 4 squared. If it's the leg I'm missing, I have square root of hypotenuse squared minus leg squared. Now, I can always just set up Pythagorean theorem if I forgot, and then solve for the leg, or solve for the hypotenuse. And I'm going to end up at this spot at every single time, which I'm fine with, and I would love that. However, when I do them, I'm going to start right from that spot, right here. I'm not going to solve every single time. I just know if it's the leg, if it's a leg I'm missing, I'm going to do hypotenuse squared minus leg squared under the square root. If I know it's the hypotenuse missing, I'm going to do leg squared plus leg squared under the square root. I'll be done. All right, so in my calculator, which I could bring it over, I guess, 9 and 4, and they were legs, so 9 squared plus 4 squared, and that is radical 97. If I hit my little toggle button down here, this little toggle arrow, I get an approximation of 9.8. Okay, so radical 97, or approximately 9.84. Now I'm going to round to 849, and I just thought of that because a lot of you, I hope, will move into calculus one day, and in calculus on the test, you have to round to 3 to the thousandths place, 3 decimal places, so might as well get used to it now. All right, and that's how you solve those now. I have a couple minutes before this is going to be 15 minutes, so I'm going to just set up the next one and solve it and be done, and then we'll do part 2 for the next part. Okay, which side is the hypotenuse and solve for x? Oh, you know what, did I figure out? Oh yeah, I did. Okay, so this right here is the hypotenuse. All right, so it's the 2 radical 3 kilometers. Now, if that's hypotenuse, that's great. I do have a hypotenuse and I have a leg, right? So what I'm going to do is I'm just going to go from the already solved spot. Well, for x. So hypotenuse is 2 radical 3 squared minus leg 2 radical 2 squared. All right, now without the calculator, I'm going to show you how to do this. It would be kind of easy, or you can just plug it in the calculator. So we have the square root of 2 radical 3 squared means 2 times itself times radical 3 times itself. All right, minus 2 times itself times radical 2 times itself. I'm going to run out of room there. Okay, that's what squaring means. Square means I have to multiply anything by itself. So what that is 4 times 3, because radical 3 times radical 3 is 3, and 2 times 2 is 4, minus, and this is 4, 2 times 2 is 4, and radical 2 times radical 2 is 2. Remember, radical 3 times radical 3 is 3. Anything radical, anything times itself is itself. So radical 3 times radical 3 is 3, and radical 2 times radical 2 is 2, which makes 12 minus 8, which is radical 4, which is 2. All right? And that's how you would do it. Otherwise, you can place it in the calculator. Make sure you put parentheses around that 2 radical 3 because you have to square it all, and around the 2 radical 2 because you have to square it all. In fact, I can just quickly put that in the calculator before we stop this video so you can see it. I have to make sure I remember 2 radical 3. So square root, parenthesis 2 radical 3, arrow out, squared. Was it minus? Was it a leg? Yeah, minus 2 radical 2, arrow out, squared. All right, so you can just plug it in the calculator like that, and you get 2. All right, move on to video 2 next. See ya.